Hi, my name is Kanter Hagleitner. I'm a committer and member of the project management committee of Apache Hive.
And hi, my name is Luis Figueroa. I'm a solutions engineer and I specialize in data warehousing and BI. So hi Gunther, good to see you again.
Good to see you, man.
Yeah, I see here that you have brought a diagram of the analyst data pipeline.
Yep.
Yeah, very interesting. Definitely a use case we wanted to talk about for some time. Okay. Now I see that you have here at the top of the diagram BI systems, and that's really interesting because many of our customers leverage such tools to extract insights from the data. So what, in the previous conversation about a year ago, we talked about Hive LLAP and how it spit up interactive queries. What enhancements can we expect from Hive 3 in this new iteration to support those tools?
Yeah, so we spent a lot of time analyzing these systems and kind of trying to find out how to best support these systems. Like you said, we wanted to get folks a snappier experience. We wanted to improve the performance. We wanted to make these systems run better, and especially in highly concurrent scenarios as well, not just single users, but you have hundreds of users on it. So one of the first things we did is we analyzed the queries that flow out of this system, right? So we took a bunch of systems, we ran a bunch of stuff on it, we took a look at the queries that came out of it, and the first thing that just bubbled to the top was there's a lot of repeated query patterns in there. Especially when you run it concurrently. I think these systems don't know when data changes, so they have to assume data changes. They make these requests repeatedly. So you get a lot of repeated query loads. So the first thing we did is we introduced a query results cache. That query results cache, anytime it sees a query, if the underlying data hasn't changed and this query has been run before, we just return the result that we've seen last time. The system manages the space automatically internally, and will just return the query for you. So what that does is, like in some cases, we've seen like an up to 70% reduction in queries that actually hit the backend. So it's a huge reduction in the kind of resources you need to run these queries.
That's awesome. I can only imagine the amount of resources that will be saved by not having to rerun these queries, especially when you're talking about petabytes of data.
Yeah,
so that's amazing.
Exactly.
All right. And then, I recall also one of our areas of conversation around the usage of these tools and interactive querying was managing concurrent access to the data and the resource constraints that might be associated to those scenarios. What's in Hive 3 that could help manage resource contention?
We've been talking about this for a long time, right? So in Hive 2, there's some fair sharing on LLAP queues, and then people are setting up multiple queues because it's kind of difficult to manage the exact access and all of that stuff. So people have been, as they grow, how many teams and how many people access these systems concurrently, they were running into challenges managing these systems. So Hive 3 has made huge inroads there. I spent a lot of time and effort on a workload management system that we built into the database directly. So now you have a whole slew of controls of who gets access to the database, how many resources can they get access to, how are resources shared, how long are they shared for, how long can you access them. So there's a lot of controls that let you fine tune how different teams and different people use the system. So as people roll out these BI systems to hundreds of users, that kind of gives you the knobs that you need to be able to have that concurrent access in a controlled fashion against your database. So definitely a lot of progress there.
Yeah. So great. So I can see how they can completely prevent resource starvation by, let's say, one big query preventing others. Okay, fantastic. I can't wait to tell our customers about that.
Cool.
Yeah. So another topic that we typically talk about is supporting EDW workloads in Hive. And I know there's been over time a lot of enhancements and improvements to further those use cases. But I heard there's a lot of new good features within Hive 3. Can you tell us a little bit about that?
Yeah, definitely. Well, so one thing, for instance, that we've added is, if you're doing offloads, oftentimes, you have table definitions and you had to change them a lot. You had to change the language you express that in. We now support a lot more of the constraints and the constraint languages that other systems do than we did before. That really helps you you don't have to rewrite these queries. It turns out this helps also when you connect these BI systems to these tools, because now that we have these constraints in the system and we know how the data actually is structured and what pieces belong together and what constraints are on the data, we can generate much better plans, and the optimizer will generate much better plans There's join reduction, group by reduction. These tools do the same thing. They can produce better queries if they know what the structure of the data really is. So that's a big one. Another one, and again, that's similar between the, using these BI systems and EDW offloads and, moving workloads from one system to another. That's the problem of not being able to change all these queries that someone has already written. Like in the BI systems, you cannot change them because they're generated. When you do an offload, you can't change them because they're typically too many.
Right.
So if you want to speed up these workloads, one important technique that you need to have at your disposal is materialized views, right? That lets you generate temporary results and tell the optimizer about it. And then as these queries come in, the optimizer will rewrite them to different temporary result sets and speed up the overall query. So you can really speed up things without having to touch the original queries with that feature.
Fantastic.
So I think that's a big benefit of Hive 3 for those workloads.
So to the end user, a query that they frequently run suddenly will be a lot faster because those materialized views are pre-aggregated and expedite the processing of the query.
Pleasant surprise, right?
Yes, definitely. Okay.
Yeah, exactly.
Really great. Thank you. Then, we have a lot of customers who are looking to embrace some of the advantages in the cloud and hybrid scenarios.
Yeah.
And I know that has also been an area of focus for Hive.
Yeah.
What new features are there to support these customers as it relates to, let's say, supporting various cloud stores across cloud providers?
Cool. Yeah, so as you say, cloud providers have been a focus for us for quite a while now. Hive 3 continues down that path.
Yeah.
All the major cloud storage systems are supported out of the box. LLAP helps with the cache, right? You can really help speed up queries by bringing the data, storing the data in the cache local and closer to your compute nodes. Yeah. We spend a lot of time optimizing the connectors that talk to these systems to make sure that for the kind of columnar workloads that we have, they access the right pieces, they transfer them at the right time, all of that stuff. So a lot of new performance improvements in there for Hive 3. And as you say, like in Hive, we actually, one of the big things that we wanted to do is to open up the system to a lot of additional storage systems and other query systems. So not only do we support these cloud storage systems out of the box, but we also support Kafka and Druid and other JDBC sources natively. And we've integrated that with the optimizer, like in a full stack. So there's a lot of new capabilities and a lot of new performance that you can get out of Hive 3 in those areas.
And that opens up a lot of new use cases that can be adopted by Hive. Real-time databases and data ingestion. Great.
Yep.
Hey, Gunther, thanks again for joining us today, and
anytime.
look forward to the next time.
Cool.
All right,
Thanks.